All right, 11.3. So perimeters and areas of similar figures, okay? So remember that similar figures do not have to have the same size, right? Two squares could be similar because their corresponding angles would be proportional, and then their corresponding angles are congruent and corresponding sides are proportional. Same with similar triangles or similar any similar polygon, right? They're not going to be the same size, they're just going to be the same shape with corresponding angles congruent and corresponding sides proportional. Okay, so with that we have perimeter and area of similar figures. So we know that the perimeter of any shape is the sum of the lengths of its sides. So you add up all of its sides and you get its perimeter. And then the area is the number of square units on the inside. It's like, what would it take to cover this entire space? Okay, perimeter is if I were to walk all the way around it, what would I need? How far would I walk? Okay, all right. So theorem 11.5 is about area of similar figures, okay? So we already saw that for perimeter, the scale factor, right? So, or the proportion, right? If you have two polygons, right, with side length of A and side length of B, right, then we could say that they are proportional and that the ratio of their sides is A over B. Okay, or B over A if we're going from this figure to this figure. Okay, well the perimeter is the same. It has the same ratio. Okay, A over B, or again, B over A. But then when you have area, and this is theorem 11.5, it tells us that if you have two polygons that are similar, with their sides being in the ratio A over B, then the ratio of their area is going to be A squared over B squared, because area is just square units. So perimeter, right, you add everything up so it comes down to the same ratio. And then area, it's going to be the same ratio squared. So A over B squared, which is A squared over B squared. Okay? All right. So if you have two similar hexagons, so that's two six-sided figures, and the ratio of their corresponding sides is 3 to 2. Right, we can write that ratio anyway. So as a fraction, we could write it this way, or you could write it as 3 to 2. They all mean the same thing. Okay? So if the sides have the ratio of 3 to 2, then the ratio of their perimeters is going to be the same. It's going to be the exact same ratio. So 3 to 2. Okay? And then the area is just you square, or the ratio of the area is you square this. So it's 3 squared over 2 squared. So 9 to 4 would be the ratio of their areas. Okay? So you just take the ratio of the sides and square it to get the ratio of the areas. And perimeters is, the ratio of their perimeters is the same as the ratio of their sides. Okay? then if you have a rectangular tablecloth, right? So we're at the top of this next page here. A rectangular tablecloth that has dimensions 60 by 120. So here is our tablecloth. Okay. And we are looking to make a placemat from the same cloth that is 12 by 24 inches. Okay. The placemat is going to cost you $5. We're going to use the area of these to find out a reasonable cost for the tablecloth then. The reason we are using the area is because what we are going to do is we're going to see how many tablecloths or how many placemats could fit in the tablecloth. So it's like you're covering it over, which deals with area. Okay, so we can say that the area of the tablecloth, they're both rectangles, so it's length times width. So that would be 120 by 6 times 60, which is 7,200 square inches. And then the area of the placemat also is a rectangle, so length times width, so 12 times 24, which would be 288 square inches. Okay, then if we want to find the ratio of the two, it's going to be the tablecloth to the placemat, and then you can reduce that. So that would reduce to the ratio of 25 to 1, which means there are 25 placemats inside the tablecloth. Okay, then you're going to use that and say, okay, if one placemat is going to cost us $5, how many dollars is the tablecloth going to cost? So we're going to set up a proportion. So 25 over 1 is x over 5. So cross multiply. So 25 times 5 equals 1x. 25 times 5 is 125. So a reasonable cost for this tablecloth would be $125. So it's saying one placemat costs $5, and you can fit 25 of those in here. So it's going to cost us $125 for the tablecloth. Okay. All right. Then we have two similar polygons that have perimeters of 7 centimeters and 28 centimeters. Okay, so we want to find the area of the smaller figure if the area of the larger figure, these are our perimeters. So this is going to be the smaller figure. We don't know how many square centimeters that is, but our larger figure has an area of 48 square centimeters. Okay, so again, you get to use ratios here because it tells us that the perimeters have a ratio of A to B. Okay, well, A to B. So that's 7 centimeters to 28 centimeters. The centimeters cancel, reduce 7 over 28 to 1/4. Okay, so that's the ratio of their sides. But then it tells us that the ratio of the areas is going to be A squared over B squared. So 1 squared over 4 squared. So the ratio of the areas has to be 1 to 16. Okay, so then we know that the area of our figure's ratio is x over 48, right? Because that's what we're given here. We don't know this area. We know this area is 48. And we found out that that ratio has to reduce to 1 over 16 because we use the perimeter to get the ratio of the areas. Okay, and you can cross multiply, so 16x equals 48, and then divide by 16. So 48 divided by 16 gives us x, so x equals 3 square centimeters is what we would expect the area of that smaller figure to be.